What makes people good at science? Is it something they learn, or are some people just naturally gifted at it? Who will be the next generation of young scientists? Where will they come from? What will they be like? And will they be able to solve the problems facing the world in the 21st century? We're going to meet 5 young people from 4 different countries who have a talent for science. We'll be finding out their opinions about science, what makes a good scientist, and how they think science is viewed in their countries.
I think we know so little of the world and of the details, how it works and so on. I think this is the really cool fact.
Science is important because it teaches us a lot and it pushes the limits onto the next level.
What also ties these 5 young people together is that they've all produced work that has won prizes nationally for science. And now they're going to represent their own countries in the 19th European Young Scientist of the Year international competition in Valencia, Spain.
I want very much to win this competition.
I'd like to win very much, but I think it's more about learning about science and having the opportunity to show the research that I've done and the work I've done on my project.
First, we travel to Brno in the Czech Republic. Josef Valorak and Thomas Nevedal share a passion for motorbikes. They've been riding motorbikes since they were young. In fact, they're completely into anything to do with motorbikes, particularly Italian Ducati motorbikes. As part of their science project, they have developed a revolutionary new slipper or anti-hop clutch for GP racing bikes. Here we see them analysing their latest clutch data and performance from the test ride. This project has given them a national science prize. Their new clutch adds a small but crucial improvement in performance through the turns. Perhaps the difference between winning and losing.
The main difference between normal and the slipper clutch is that the slipper clutch has unusual degree of the second ramp, this aging ramp, and it allows clutch to slip if there is too much power and the rear wheel is beginning to slip. In our clutch, we use the unique degree of the disengaging ramp. Normally they are used 45 degrees, but we use the 52 degrees. And also we have here some holes from the ball bearings, which allows the delivery of the slipping of the clutch to be smoother. Just a whisker faster in the turns.
Having developed a racing clutch for their science project, they have actually become ambassadors for racing parts to bikers in Brno. But what are their thoughts about science in general in the Czech Republic?
Science is important because it teaches us a lot and it pushes the limits onto the next level. Unfortunately, the reputation of the science in Czech Republic isn't so good.
Czech people don't have money for the science, and a lot of our good people in the science go to other countries in Europe.
The science that goes into motorbike engineering is a far cry from the schoolwork they were previously used to. What have they discovered about being involved in a practical project like this?
For sure, the patience, endurance. I think there should be a passion and skill of communication with other ones. The capability of making money, because you must have some money to start some project, and you must be a good speaker to announce your inventions.
It's not about what I study or learn, it's about my head and thinking and testing new things before I share it with the whole world.
Away from the roar of motorbikes, Martina Hafner is another National Young Scientist winner from Braunau. Austria. Here, the farming community grows maize each year. But after the harvest, there is a considerable amount of wastage left over. Martina decided to develop a process to generate biogas energy from this natural waste.
Here you can see the whole maize plant, and it's used for human consumption and for animal feed as well. For this it will be cutted here near the floor. So the leaves and the stove will left here on the floor, and so I thought producing biogas is the best solution for getting energy of the leaves. But the problem for biogas is that the biogas bacteria in the plant are not strong enough to break the celluloses, which is the main content of the leaf, to break it down. So my work in the project was to find a really good chemical to break the celluloses.
Her college has always promoted science, and this has had a big impact on Martina. She is very positive about the effects of science on the world around her.
It's fascinating. I think we know so little of the world and of the details, how it works and so on. I think this is the real cool fact. My inspiration for science is my work with the projects, and I have a very good teacher, and he inspired me to do some scientist's work.
In her spare time, Martina and her friends are volunteer firefighters. In all, there are about 100 local volunteers who keep the station open 24/7. What do they think about scientists?
Ich glaube, sie sind ein wichtiger Bestandteil unserer Menschheit, dass sie durch ihre Forschungen viel erreicht haben.
Ich finde, Wissenschaftler sind wichtig, weil die Menschheit ständig nach Neuem strebt, nach besseren Innovationen. Und ohne Wissenschaftler waren wir heute vielleicht nur in der Steinzeit und dann in Höhlen wohnen.
Martina's project to produce biogas from the waste in the fields around her home in Braunau won her the prize of Austrian Young Scientist of the Year. Meanwhile, in the UK, Anna Ressel has just finished her A-levels at Cardinal Newman College in Lancashire. She won a summer placement to become a part-time chemistry research student at the University of Central Lancashire. And this led her to become a UK National Young Scientist of the Year winner. What are her thoughts about science and scientists?
I think the main purpose of science is to increase the quality of life for society. Whether that be through medical advancements, or also I think a really important role is its role in the environment. I think that a lot of damage has been caused by science, and its role today is to reverse that damage.
The research team that Anna worked with at the University of Central Lancashire is currently working on a method to remove poisonous chromium-6 from water and recycle it back to the environment.
Chromium can be released into the environment through a lot of industrial processes, such as the manufacture of steel, leather and textiles, and also chemicals. It's a carcinogen, so it can cause cancer. Also, it can cause respiratory problems, liver problems. It's toxic to all organisms, so if it gets into the environment, it can cause a lot of environmental problems as well.
What skills does she feel are relevant to being a good scientist?
I think to be a scientist, you've got to be naturally curious, and I think there's always something new, there's always something exciting going to happen. You never know what's going to happen, you never know what you're going to discover, and I personally think that's really cool. Most of my friends are actually science students themselves, so I think their perceptions of scientists will probably be pretty accurate. I think they understand that scientists can be doctors, teachers, professors, as well as researchers. So I think their perception will be pretty accurate.
Scientists can all be completely different. I've got friends who are very bookish, who are scientists, and scientists who are kind of socially quite mad, out drinking all the time. All sorts of different scientists.
I'd say they have a natural curiosity. They're like proving things, disproving, experiments, testing.
I suppose we're all quite hard-working. We can be a cliquey bunch sometimes, but we're generally friendly. We get our work done, we work hard and we play hard.
Further south in Monza, Italy, Gabriele Maini attends the Politecnico di Milano, studying engineering. The area has a heritage of great arts and culture. Yet, Monza is home to the famous Formula One track. Here are some of the finest examples of high-tech engineering in action. Gabriele would eventually like to be an aeronautical engineer. In fact, he was challenged by a friend to see if he could make a rocket that would fly, but only propelled by water. It was the success of this rocket which put him on the road to becoming a National Young Scientist winner for Italy. What does he think about science and scientists?
The most cool things about science is she found easy answer to difficult questions. Because science asks itself why things works and give an answer.
Gabriele spent the first part of his project in this garage, constructing his rocket prototypes from simple household materials.
I think that the main skills that make of a people a scientist are the curiosity and the willing. If a person is very keen on a thing and continues fighting for his ideas, for developing his ideas, he could be the finest scientist.
Armed with his experimental rocket, Gabriele proved a rocket powered by water really can fly. His college thought it would be a good idea to take this bet and turn it into a piece of mathematical research to calculate the flight trajectory for this kind of rocket. Professor Laura Malgrati is one of Gabriele's science tutors at the Politecnico di Milano. She explains why she believes Gabriele would succeed in his scientific endeavours.
Gabriele è un ragazzo dotato di molta curiosità, cerca poi di capire quali sono i meccanismi che regolano appunto i fenomeni che osserva, cerca anche di sfruttare le conoscenze matematiche che ha per dare una veste matematica all'osservazione che lui ha fatto e questo gli consente appunto di proseguire nella sua conoscenza e nella sua ricerca.
However, the mathematics for calculating the acceleration, speed and distance of a flying water bottle that is dynamically changing mass and pressure is hugely complex. Rather than try and analyse this too rigorously, Gabriele adopted a unique approach. He was sure he could build an experiment to statically emulate the flight of the rocket, analyse the data and predict the likely performance of a real rocket in flight.
I built a device and I attached the tank to this device so that the tank acted on a force sensor and the force meter measured the thrust in time. This project is very related with my aeronautical interest because I always loved things that fly, and so my dream was to construct something that flies by itself and to predict his flight path.
Ha lavorato quindi in modo del tutto autonomo su questi punti, chiedendo ogni tanto qualche consulenza, ma le idee per la risoluzione dei problemi sono state del tutto originali e del tutto frutto della sua mente.
Once finished this experiment, I obtained a lot of data, and to analyze that, I used the computer, and I obtained the acceleration, the speed, and the space. Once obtained the space versus time graphs, I would be able to understand the length of the flight. So if my flight time prediction is very accurate, I can state that my prediction of maximum height is very useful.
Gabriele had the theoretical predictions from his lab data. Now he had to test them to measure their accuracy. For the theories to be correct, he hoped for an accuracy of within 20% of the predicted distance travelled by the homemade rocket.
And so we're ready for the launch.
The calculated time for the flight and the predicted time were indeed within 20%, and Gabriele went on to win an Italian national prize with these results and process. What did his friends think the competition would do for his future?
Beh, questo concorso potrebbe aprirgli le porte del lavoro e comunque dargli una grande mano all'università, è comunque una bella esperienza che lui ha fatto o che farà.
Beh, Gabriele si è molto impegnato in questo progetto, si è applicato molto e ha dimostrato come la scienza non sia solamente qualcosa di astratto ma anche di concreto.
In Austria, most of the maize cropping for the year is nearly complete, and Martina has collected the waste leaves from the fields. These are the raw ingredients to make natural biogas. The leaves have to be dried and then have to be pre-processed for best results. Martina developed many different methods of pre-processing before deciding on the best technique for her project. Getting a decent amount of biogas was very difficult at first. The cellulose in the leaves was difficult to break down, so Martina devised methods like cutting the leaves into small parts, soaking in sodium hydroxide, and then cooking for 48 hours in a warm oven. Part of the problem was that her project is quite unique and there isn't a lot of research to study.
Mostly we find information about paper industry, so because they work with celluloses too and so on, and we can't work with such information. The first really good page was about making cow feed out of straw, and it was a very similar process and very similar experiments to our work, and so it was a really luck to find these pages.
Then she adds this to a potent bacteria solution which produces biogas as a byproduct. However, the results were still very variable.
The main problem was to keep the process stable, because it was very hard to handle with the bacteria. They are very sensitive, and just temperature and pH values and so on, it was very difficult to handle with.
To maximise the quantity of biogas produced, the maize leaves and bacteria were put in a temperature-controlled bath and held at a constant temperature of 38 degrees. The biogas was then collected through bubble locks. Dr. Wagner was Martina's supervisor for the project. HTL Braunau prides itself on its project work, particularly ethical projects.
Für uns in unserer Schule ist es wichtig, dass Schüler Projekte machen in der Abschlussklasse. Und wir als Lehrer und als Team in der Schule stehen hinter diesen Arbeiten und unterstützen die Schüler, wo es nur geht. Wir sind weniger Lehrer, wir sagen immer dazu, wir sind dann Trainer.
Here we see our first bubble of biogas. Each day, Martina would record how much biogas had been produced.
Ich glaube, Martina hatte deswegen Erfolg, weil die Arbeit gut aufbereitet war, weil es eine Arbeit war, die mehrere Disziplinen einschließt, und weil sie es einfach ernst genommen hat. Sie hat ein ordentliches Produkt abgeliefert mit einigen doch nicht ganz alltäglichen Ideen.
However, Martina didn't stop there. She felt this research could be scaled into an industrial process that could benefit the local region. They already have a pumped water thermal system running under the river, shared with their neighbouring German town. So Martina approached the local mayor to see if he could use his influence to get the project adopted.
Martina war vor circa einem Jahr bei der Stadtgemeinde und hat sich erkundigt nach den Voraussetzungen, Grünschnitt und dergleichen für das Projekt, das sie bearbeitet. Hallo Martina, guten Morgen, freut mich. Und der Stadtgemeinde war eigentlich von Anfang an klar, dass sich eine Kombination dieser Projektüberlegung mit den Voraussetzungen vor Ort ganz gut finden lässt, und das ist auch ein Grund, warum die Stadtgemeinde diese Projektumsetzung, wenn sie hoffentlich gelingt, ganz gerne unterstützt. Wenn man berücksichtigt, dass dieses Wiedernutzen und Ressourcen nicht verschwenden, dass das also bei allen Umweltüberlegungen eine zentrale Rolle spielt, dann wird dieses Projekt ganz bestimmt beispielgebend sein.
So Herr Schieber is hopeful that if Martina can clearly demonstrate the efficiency of her process, then he should be able to help develop her project.
A good outcome is that he will build up a very special biogas plant with my ideas and my development, and this would be the best thing.
At the same time in the UK, Anna Ressel won a bursary placement in the chemistry department at the University of Central Lancashire. This allowed her to join a PhD project group from within the university. Quite a gear change from the level of science she does at school. Dr. Gary Bond, senior chemistry lecturer at the university, believes that having school students on placements there is a great way for young scientists to find out exactly how real research is carried out.
The Nuffield Bursary provides students with the opportunity to work within a university laboratory, but maybe more particularly to working in a research environment, rather than a classroom where they can work on project work and really become involved in the science.
Now, one of the problems with aluminosilicates...
It's a lot more flexible and a lot more relaxed. For that reason, you've got to be quite determined and quite focused, because otherwise you get sidetracked and distracted. So, whereas school, it's a lot more strict and they keep you doing your work.
For PhD student Kimberly, it was quite unusual to have a school student on her research team. How did she find having Anna as a researcher?
I really enjoyed the fact that she questioned my thinking, and she wasn't willing to just take what I said as at face value. She questioned what I was saying, which is what you have to do in research. You have to push the boundaries, you have to question everything.
Anna was involved in a project to develop a chemical method to remove poisonous chromium from industrial waste.
Now here we can see the peaks of chromium-3 starting to come out of the machine. Okay. We will get 3 peaks.
My project was quite an environmental project because chromium has such an adverse effect on the environment. If it got into water supplies or it leaked from industry, it would be quite harmful. Therefore, being able to contribute to research that could potentially prevent damage to the environment being done, I found really interesting, and I thought that was important. Obviously, when I first started, I worked alongside Kimberly, and she helped me with the equipment and showed me how to use it. And then once I got the hang of it, I was able to use it on my own and just get on with my research.
What made a difference with Anna was her enthusiasm and the fact that she took ownership for the project and what she was doing.
When she returned to Cardinal Newman College, Anna was entered into the UK National Young Scientist competition. Her college supported her by having a huge poster printed for her project, her research and her results. This she took to London and won a UK Young Scientist prize. Rachel Atkinson, her school mentor, believes the competition had a profound effect on Anna.
I think meeting like-minded people has been a wonderful experience for her. She has the ability to capture other people's interest and enthusiasm for her work, and that she has been given the encouragement to see herself as a successful scientist in the future. Brilliant work. Thank you.
Away from the seclusion of academic research, Josef and Thomas were having their product tested on the Brno International Rate Circuit. A far cry from their schoolwork. Again, the school encourages students to get involved in their own Czech National Young Scientist competition. But how did Josef and Thomas choose the subject matter for their project?
We thought about the national competition, what will be great to get a success in this. And we thought about coming to the racetrack and linking the theory with the practice. And first stage was actually in the class, because we must present our ideas and our basic lines of the project before the class and before the teacher.
At first we had to write whole work. We was writing it, I think, 5 days non-stop.
Ms. Pilarova is Josef and Thomas's mentor from their high school. She was very impressed by their ambitious project, based well away from any schoolroom.
Na projektu je výborná myšlenka, že opravdu středoškolská odborná činnost může přinést nějaké konkrétní výsledky. To znamená, od té teorie, se kterou ty studenti začínají a vycházejí z ní, se můžou dostat až k těm praktickým otázkám.
We went to the circuit in Brno and there we saw Mr. Točka and went to him with ask if we could make some interview with him about Ducati because we are writing about Ducati and slipper clutch.
Jiří Tříška is the Czech JTR course racing team owner. He has been racing motorbikes for many years. He was very impressed by their knowledge and research into Ducati motorbike technology.
Že je zajímá můj vynález spojky, že je zajímavý závody všeobecně, takže by prostě chtěli si udělat diplomovou práci v tomhletom duchu. A jestli bych byl ochoten jim nějakým způsobem pomoct. No, takže jsem jim prostě samozřejmě neodmítl.
Startovací, takový ten klíšek. We were discussing only with Mr. Tečka something that finally could be used.
Ten klíšek tam je proto, byli se mnou párkrát na závodech, povykládali jsme o tom o všem, oni se podívali, udělali si nějaké fotky a vlastně začali pracovat na té diplomové práci.
So, they had their design and using money from their family and sponsors had the first of many prototype clutches manufactured.
The first difficulties was that we think that it is easy, but it's not.
We were going to races and there we were testing the clutch.
Hnacím motorem pro tento projekt byla bezesporu snaha obou protagonistů se dostat co nejhlouběji do toho zázemí těch motocyklových závodů.
Their innovative slipper clutch design then went on to win them a Young Scientist Award for the Czech Republic.
It was the real dreams come true. We are over the moon that we can say that our parts are used in the race bikes. So it was my dream to get involved in the race world, not to be a normal fan, but to be something like a part of the team or so.
So, 4 projects and 4 sets of students from 4 countries. However, the game is about to be raised. The venue, the fantastic futuristic city of arts and sciences, Valencia. The EU is running an international competition to find the very best young scientists. 80 students from 32 countries will be going head-to-head, judged by some of the best academic scientific minds in Europe. Dr. Colin Pullum, a jury member, explains.
The purpose of the international competition is really to celebrate and reward the young people, young participants engaged in science and engineering. And I think one of the real benefits of the competition is not only to celebrate their achievements, many of them have worked very, very hard for long periods of time, many of them have come up with new discoveries, exciting discoveries, but it also is a chance for them to meet other scientists. Many of my colleagues on the jury are very distinguished in their own field, and it's a real privilege for the young people to actually meet these distinguished scientists, but it's also, I think, a real privilege for the scientists of the jury to meet these young people, so it's a very much a two-way process.
However, it's more than a competition. It's an opportunity for our young scientists to meet other young people, see a modern, vibrant city, and present their work to professional scientists. But they'll be competing against the crème de la crème of young scientists from the rest of Europe. How important is this competition, and how do they rate their chances?
It's very important for me, this competition. I want very much to win this competition.
I'd like to win very much.
I don't know. I think everyone who is invited to this content is a winner, so...
I don't know, it's very hard to say. I let it on other people who choose the best.
This will be the first time these students have competed outside their own country. They'll be judged against their international peer group. How do they feel about this?
I will be nervous because of English language.
To explain everything in the best way to everyone.
That I left something important, really important at home.
I think the judging will be more intense than it was in London.
English speaking, it would be the biggest problem, I think.
Be able to meet young people from all over Europe and find out about their science projects, and I'm also looking forward to seeing the city.
It's the day before the competition starts. All our students will be arriving today at Valencia Airport. They've packed their projects into special containers and hope that they'll all arrive safely. The organisers have arranged accommodation and transport throughout the day. First to arrive are Thomas and Josef from the Czech Republic with members from their country, Martina and co-contestants from Austria, Gabriele arrives from Italy, and Anna from the UK. For these students, it's a chance to catch up with the other contestants from their own country. The last time they met was in the national competition in their own countries. The Austrian team has 3 projects. 2 are actually from Martina's college in Braunau, then on to their coaches to take them to their hotels for the first night in Valencia. It's the first day of the competition. All the students arrive at the City of Science and Arts. They have to register with the competition organisers.
Good morning.
They're given their passes, specially designed bags, and directions of where to set up their projects. In the hall, each student has now been allocated a stand. They've brought posters and models, in fact, anything they think will impress the judges. However, it's not all going according to plan. The Danes have been allocated a stand with a desk on the wrong side for their carefully created display. They're not very happy and want to have the stand altered.
Try to get another table.
Could you not just get a hammer and then break it down and then you get another table on the other side?
Okay, wait, no. But we'll see for the table.
Okay, but a table on the other side for tomorrow, that would be really, really great.
Okay.
And they're not the only ones with difficulties. Not everyone's displays have arrived. Our teams are busy setting up their booths. Martina has brought maize plants and leaves and sets about recreating an Austrian field in her booth. Gabriele is busy reassembling his rocket. Thomas and Josef are making sure that no one is in any doubt about which type of motorbike their clutch is being used in. And Anna, having put up her poster and with her laptop on, has a chance to study the week's busy schedule. At the same time, the judges arrive at the museum. This is not the first time they have seen the students' work. The projects are allocated to subject specialists, and the research documents have already been studied.
The projects are allocated and we have about 2 months to look at those and assess them.
So the judges have to make an individual assessment for each project before they even meet the students.
We read them all. We have a previous meeting 1 week before the contest in Brussels, and we give the first judgment.
Each student now has their booth set up. There are 80 booths arranged by country. There are engineering projects, projects around biology, chemistry and computers. There are also environmental science, maths and physics projects. In fact, all the major scientific disciplines are covered. Deciding if a social science project is better than a medical one is no easy task. So how do the jurors make their decisions?
I'm looking for innovation, ideas, bright students, and always the spark that they have, and also the interest for their respective fields.
We want to see original research where a new angle has been taken on a subject. So we want to see in the young people a challenging of accepted wisdom.
For the next 3 days, the students are going to be bombarded at regular intervals with questions about their projects from members of the jury panel. The judges are looking for originality and creativity in the presentation of the students' projects and in the students themselves.
I was investigating an influence of coal-fired power stations on the environment in Poland, and I've collected 47 industrial and non-industrial samples. I've collected, coal from power stations and all this stuff. Also, I've investigated that the contamination of soils in Poland are mainly due to individual users of coal, not the big industries.
I was testing if spices could be used as preservatives on cooked rice. So basically I took cooked rice and added spices to them and tried to see if they had any antifungal properties. So I let them grow all moldy and smelly, and then I saw how quickly the fungus grew on them. And then I found that on cloves and cinnamon, I had them there for 7 days, but there was no fungus on them.
Well, we were working on the metallic corrosion, which is one of the most burning problems nowadays. And what we tried to do is not to invent a new coating, but to see what are the features that determine the best speed for corrosion. We have discovered that there is a big possibility to make new coatings that would protect steel from corrosion.
The jury rounds last all morning and all afternoon. There are lots of projects for the jurors to see, and it's the main opportunity for the students to impress the jurors with their knowledge and the inspiration for their projects.
We use 15% less gas, so we know that we can drive 15% longer per litre of gas. It's because of the explosion in the cylinder. Yeah.
The main thing is to see that if the idea is a new idea, and also the means that they have used to develop the ideas.
My project is on an attack on an RSA crypto system, and a crypto system, what I mean is encryption, and as you can know, like every single time everyone is afraid when you're using your credit cards in the internet, and what I'm showing is the possibilities that I can get your numbers.
These projects are invariably of very, very high quality. They're all national winners of competitions. They're very, very bright and enthusiastic young people, and that really is quite fantastic.
For Martina, Gabriele, Anna, Josef and Thomas, it's been quite a day. So how did they find their first jury round session?
I'm surprised that they didn't want to know some numbers or something like that. They was only asking about Ducati for us, how we work with Ducati, if we ride, and so on and so on.
The first judge round I had one visit from a French judge, and I was quite scared about it because I didn't know the exact question that she could make. But I think that I gave good answers, and I'm sure that I answered to all questions she made me.
The judging is sometimes quite difficult because they ask you to be quite brief, and it's really hard to be brief, so I've always got loads to talk about. I can go on for ages about this project, so that won't be a problem if they come back again.
The jury is going around, and after a while one of the juries coming to one stand, and they ask you something about the project and so on, and most of them had only 10 minutes time to ask you.
The juries are pretty strict, so everybody is a little bit scared, I think, but when it comes to the real one, the presentation of your work, it is nice, they are lovely.
It's been a long afternoon, but the students' time in Valencia is balanced with other activities.
Let's get started.
Dr. Freya Bleckman, a leading scientist from CERN, the world's largest particle physics laboratory, has come to talk about the work she does in particle physics and the fantastic career opportunities science has afforded her.
This is the first time when you really start to do things that have never been done before, when you become an expert.
CERN is Europe's laboratory for particle physics. This is where nowadays even the rest of the world comes and studies the nature of the universe and also the nature of the smallest constituents of matter. And it's one of the largest research institutions in the world.
CERN is also part of a wider international science group called Aeroforum. Aeroforum looks after 7 of the major research institutions in Europe, including CERN.
Physics, experimental physics, is very...
Aeroforum is here not only to promote the fantastic science opportunities in Europe, it is also soft recruiting the next generation of top European scientists, many of whom are in this audience.
You do equations. It's really something else every week, which is really nice.
ERA is interested in smart people, and there are smart students here, smart potential Nobel Prize winners, so we want to make sure we get our share of the deal.
It's day 2, and already there are projects that seem to be arousing a lot of interest from both the jury panel and the students.
The really varied project. There's actually one that's quite similar to mine about water purification. So I've not had a chance to go and have a look at that yet, but I do intend to have a look, see what they've done about. I think the medicine ones are really interesting. There's one about nicotine.
I really like the Denmark one, and also there is some project about the wine, so I hope that it should have a good result.
I saw the water cooling processor. Yes, it was very cool. So the blue lights and so on is very great. So it's my favorite.
I saw a project from an Irish student, which is very difficult to understand. It's a mathematics project, but very amazing. Even other projects, for example, sound education and music education for deaf. I'm interested in understanding more.
One project by Henrike Wilms and Florian Ostermeier from Germany seems to be getting a lot of attention. Their project came about from a very particular observation, which triggered a series of questions in their minds and was the basis for their research.
I have made an observation in a stalactite cave that a droplet that falls down from the ceiling flashes up at a certain height really, really bright. And I couldn't explain why a water drop should flash up at a certain height.
It's really curious because if you change your position towards the droplet, this reflection changes, and that's what our observation was and what we had a closer look at.
So we can define the oscillation of the droplet and we can say where these reflections occur.
Another interesting competitor attracting an audience is Johan Jensen from Sweden. He has been observing Darwinian evolution in birds in his country.
I've been comparing two different populations of this specific bird species, the bearded reedling, one from Sweden and one from Hungary. And well, I've found differences between these two populations, and the character of these differences suggests that these differences are actually a result of the bearded reedlings adapting themselves to the climate in Sweden. And that is in line with my hypothesis, so that was what I wanted to show, and that is what I have shown.
Another popular project, also from Germany, is Florian Schnoss's 3D camera, with a fantastic moving robot arm and 3D eye.
The project is about developing a universal 3D camera. So it's a camera which doesn't only give you a normal picture, but for every single pixel of this image you get a defined depth information. So you know, for example, how far is the object away from the camera on the image. You can use the camera, for example, in medical engineering. You can use it in industry, you can use it in road traffic to avoid collisions, for example. So it's really a universal 3D camera. You can use it outdoors, indoors, to measure a very small, tiny object, or to measure the whole environment.
After the second day of intense jury rounds, the students go on to their evening's entertainment. Hosted in the university's amazing botanic gardens dating back to the 16th century. The students start with a tour of the gardens and then, with the aid of some quite fantastic helpers, are shown to the party for well-earned drinks and food. They're entertained by musicians, magicians and dancers until the sun goes down. It's day 3. Outside the museum, life continues as normal, but inside, the pressure is mounting.
The judging seems to be getting a little bit more intense now. We're having a lot more judging during the day, whereas yesterday I didn't have that many visits, but I've had quite a few today, so it seems to be getting a little more intense, a little more difficult, and everyone's getting a little bit nervous because the judging finishes today and we find out who's won tomorrow, so it's quite exciting.
I've got 2 questions which I can't answer, and it's a bad feeling, but in the whole same it's very good. So.
Yesterday there weren't 3 judges, and they seem to be more interested in my project than the other judges. And I think that I have made a good impression because they answered me the question that I really want to answer to. And so I'm very happy about this.
In a private room, the 15-strong jury meet for the last time. They now have to decide a rank ordering for the students' projects. It's a mix of the students' concept, the scientific process they've undertaken, their write-up, and the way they've communicated their project to the judges here in Valencia. It's never easy, and even among the judges, there can be disagreements.
I personally don't like to see nerds. I want just to see a real person, a real youngster, and a role model for the youngsters. And I don't think a real model is a youngster who stays 24 hours in front of the book.
Back in the hall, there's a late arrival. One of the projects uses a huge Tesla coil, the sort of machine that can generate large bolts of lightning. The trouble is, it never arrived.
I waited until this morning to come and visit them, to give them the best chance. This big piece was not here. It has arrived. We've broken up our meeting just to be sure that they have the same chance as everybody else. They are lucky and unlucky. You know, if they were luckier, it would be here. If they were luckier, it would be here earlier. But they have 13 minutes, so we have to talk quickly with them. They have to talk quickly with us. Maybe a little bit of privacy.
We have to visit all of them, not only once or twice. Otherwise, the students get an idea of who will be the winners. And one thing is very good, in the award ceremony, not a single person except the jury members and the one who has signed the prizes know who will be the winners.
Even though the students don't know for certain, there are definitely opinions about likely winners.
I've seen a really good project from Austria, a boys synthesizer molecule, which I think has got a really good chance of winning. It's actually chemistry, so it's kind of a bit of competition for me.
Israel may win a prize because the jury is always there. If you look to an Israel project, they always have a judge, almost a judge, maybe 2 or 3.
It's 5 o'clock, and that's it for the final jury round. There's no more the students can do. Now they can finally relax and enjoy the splendor of the beautiful Palau de la Exposició. Time to talk about their week and share experiences. Gabriele, Thomas, Josef, Anna and Martina share a drink before a fantastic concert from the University Orchestra in the Palace of Music. It's the final day in the Students' Week in Valencia. Here, in the Oceanographique, the largest marine complex in Europe, the students assemble for the finale. This is the moment they've all been waiting for, the culmination of their project work over the last year. There are many prizes to be won, but it's the core prizes of 1,500, 3,000 and 5,000 euros that the students have got their eyes on. The judges have finished their deliberations and come to a consensus. There are awards at each level for different subject specialisms.
Now, the moment you have been waiting for has arrived. The third prize winners. Development of a universal 3D camera, Florian Schnoss from Germany. Generalization of methods of tiling in triangular hexagonal grid by Eva Czernowska from the Czech Republic. For the second prize winner is In Energy from Maize Straw by Martina Hafner from Austria.
And finally, the top prizes of €5,000 each.
An extension of Winner's Attack on RSA encryption by Abdullah Sam Abudakar from Ireland. In Physics, Flashing Water Drops by Henrike Wilms and Floria Stermeyer from Germany. In Chemistry, Examination of the Plant's Self-Defense Against Pests by Márton Strón from Hungary.
Straight after the awards, the winners have to give a press conference in front of Spanish journalists and TV cameras. Martina is asked how she feels about winning her prize.
It's a great pleasure for me to get this prize, and I've not expected to win it, and so I'm very happy about it. And for the future, I hope it gives me some inspiration for my studying too.
It's all over. There have been winners and losers, and along the way, many new friends have been made. How do Gabriele, Anna, Martina, Josef and Thomas summarize their week and the competition?
I'm great happy with my prize, so I don't expect it to win anything, and so the second prize is a very good prize, and it's the best finishing for this week. So
passed a fantastic week. Before coming here, I never think that I will had an experience like this, because everything was okay. It was very brilliant. Both the museum, the exposition, the stands, people, new friendship, going out in the evening with other people of other countries. So it's really fantastic.
I think the best thing was the enjoying of the time with another scientist, because sometimes you think scientists are weird and you're the only one, but you are certainly not.
It's not true that all scientists are geeks. I think that's been proved here, but just by the complete variety in the people that are here, that scientists don't fit a stereotype at all.